So today we're going to look at points of concurrency. Okay, points of concurrency are simply where multiple lines intersect. Should I be more specific? It is the point where multiple lines intersect. Now they could be lines, they could be segments, it could be rays. Alright, so a point of concurrency is a point where multiple lines intersect. Quit.
Were you here this time?
Yes, multiple. All right, so an altitude. Now, our lines are going to be some form of an altitude, an angle bisector, a perpendicular bisector, or a median. Okay. As I stated yesterday, there are 4 points of concurrency, but we're only going to look at 3. All 4 used to be in the curriculum many years ago, but they've taken one out. Okay, so an altitude. Okay. All right, when we talk about an altitude, a lot of times you probably hear about like the altitude of a plane. What's altitude talking about when it's talking about the altitude of a plane? The height. Okay, so an altitude in a triangle is a segment from a vertex perpendicular. And recall that perpendicular means intersects to form a right angle to the opposite side. Now, majority of your altitudes are going to be inside the triangle, but sometimes for your obtuse triangles, some of them might be on the exterior of your triangle. Focus now. All right, an angle bisector. Denisha, put the phone away. All right, what is an angle bisector going to do? It's going to bisect the angle. Okay, so an angle bisector of a triangle is a segment from a vertex that bisects the angle into 2 congruent smaller angles. So this larger angle right here, the angle bisector is bisected into 2 congruent smaller angles. All right, so an angle bisector is a segment from a vertex that bisects the angle into two congruent smaller angles. So like if this was angle A right here, angle A is being bisected by the angle bisector into two smaller angles. So this little angle here would be congruent to that little angle right there. So like if this whole thing was 80 and this is being bisected, what's each little angle going to be? 40. All right, now we've got a perpendicular bisector. What does perpendicular mean? Intersects to form right angles. What does bisector mean? Cuts it in half. So we've got something that's intersecting to be a right angle, but it's also cutting it something in half. So here, a perpendicular bisector is a segment that is perpendicular to a side at its midpoint. Now notice I didn't say it bisects it. I said it's perpendicular to the midpoint. Think about the definition of midpoint. Midpoint says it's a point in the middle of a segment, right? So it's dividing that segment into two equal parts. So this part right here is equal to this part right here. Well, if it's perpendicular, it can go straight down to that. So here we have a perpendicular bisector. So it goes from the vertex to the midpoint of the opposite side. Now, as you finish copying this, sometimes when we have diagrams, it might not look like it's supposed to look, but sometimes it'll say picture not drawn to scale, which means they just kind of drew it up there, but it's not really to scale. But you always go by what you are given and not what it looks like in diagrams. Okay. Segment that is perpendicular to a side at its midpoint. All right. Median. What word does median kind of make you think about? Middle. Okay. So a median is a segment from the vertex to the midpoint of the opposite side. And I'm going to abbreviate opposite. So it's very similar to the perpendicular bisector, except for it doesn't have to be perpendicular. So here's our midpoint. That's showing that it's two equal sides and drawing it from the vertex. Now, notice here, 3 out of those 4 statements says it's a segment from the vertex. The perpendicular bisector doesn't say it's from the vertex, does it? Sometimes it will be from the vertex, sometimes it will not be from the vertex, depending on the type of triangle you have, whether it's obtuse, right, or acute. So these are the segments that make up our points of concurrency. our 3 points of concurrency that we're going to talk about in this unit are incenter, circumcenter, and centroid. The one that has been taken out of the curriculum is orthocenter. Okay. All right, so let's look at our points of concurrency. So we completed our foldable activity yesterday. Okay, so we're going to look at the incenter. All right, so your incenter is your POC, your point of concurrency, created by the intersection of all 3 angle bisectors. All right, it has 2 special properties. The first one is that it's equidistant. All right, so what's the prefix equal mean?
The same.
The same, they're equal. So it's the same distance from the sides of the triangle. And then your second property is that it is the center of the inscribed circle. Equidistant, yes. Equidistant. Equidistant. Yes, never be afraid to ask about my writing. There's no shame in my game about my writing.
Having a good day so far?
So far?
Have you had a bad day yet?
On bad day I've had, it's like when I'm driving here or driving home, I get behind some people who can't drive.
Right.
There's some young drivers that might do some equal. The people that you got beat.
No, I drive fine, and I park fine as well. It's Haley that doesn't. And I always make sure.
Equidistant. That's a fancy way of saying the same distance. Equidistant.
But Haley parked so close to me, I couldn't even open my door. I had to go across and just open my door.
She leaves after second period, so I couldn't do it too far.
All right, so right here we have our point of concurrency. All right, and because this is the angle bisector, all 3 of these angles have been bisected. So since that's the point of concurrency, what is it called? Incenter. When you have all 3 angle bisectors intersecting at a single point, that's called the incenter. Now, yesterday I could not find my compass, so I borrowed one from someone. So I'm going to show you what it means by this right here, the center of the inscribed circle. All right. It is equidistant from the sides of the triangle. So this segment right here, these 3 segments right here. Equidistant. Equa. The prefix EQI. It's a prefix that means equal.
Oh, okay.
So those 3 right there are equal. So these right here would always be the same from the point of concurrency to the side. What it means by inscribed circle, if I take my compass and I draw a circle. Oops. This one is not as flexible as my, alright, there we go. I had a little bit of movement on my compass, but basically, you see how this circle is formed on the inside? The length of that right there, if you use that as your compass radius, that will give you an inscribed circle which would touch all three sides. Now my compass moved a little bit, so it's not a perfect example, but you at least see the idea of it. Okay. And as I said yesterday, what does in center start with? N-I-N. What does inscribed start with? N-I-N. So that's an easy way to remember that. All right. A circumcenter. All right. The prefix circum. All right, like circumnavigate. If you circumnavigate the earth, what are you doing? You'll go around the earth, right? So circum means around. So keep that in mind. A circumcenter is a point of concurrency, a POC, created by the intersection of the three perpendicular bisectors. Right. Its special properties is that it's equidistant from the vertices intersection of the three perpendicular bisectors. And the circumcenter is the center of the circumscribed circle.
Birds playing noise. Sorry, is that a propeller? Bird thinks he's in raid.
This right here,
I think he's part of
it's an inscribed circle. Circumscribed. So equidistance from the vertices and center of the circumscribed circle. All right, so these are perpendicular bisectors. So we've got to find the midpoint, and then it's got to be perpendicular. All right, the midpoint, and then it's got to be perpendicular. The midpoint, and then it's got to be perpendicular. Now, like I said, sometimes they're going to go to the vertex, sometimes they may not. It doesn't have to. The other ones do have to come from the vertex. but the perpendicular bisector does not. So here's our point of concurrency with all three intersect. Since it's, let me mark these real quick though. Alright, so since this is the point of intersection of our perpendicular bisectors, what is it called? A circumcenter. Alright. These pieces, these segments right here that I just highlighted are the congruent ones. Okay. All right. Now, it is very, very easy to get the two confused because in an in-center, the shorter segments are congruent. In a circumcenter, the longer segments are congruent. Okay, so I'm getting ready to give you a hint of how I remembered this when I first had to start teaching this. Because like I said, when you go to school to be a math teacher, the math you learn is not the math you teach.
The friends you meet along the way.
Okay, so you pretty much have to kind of teach this math to yourself. So the way that I remembered this, these are the shorter segments, right? Isn't in-center a shorter word than circumcenter? Yes. So the shorter segments go with the shorter word, and circumcenter is the longer word, so the longer segments go with the longer word.
Oh.
And just remembering that will help you. Our last point of concurrency is the centroid. So the centroid is the point of concurrency of the three medians. Now, like I said, this is the important one. This is the one that I have seen on most of the release tests for the state. So I see this one on most of the online programs. So the medians.
So your test is statement?
The final exam is, yes.
Is math for statement or?
Yes, ma'am. Make sure you take those earbuds off. You know, I'm not even supposed to see them. All right, the longer segment is twice the shorter segment, and I'll show you what I mean by that in just a minute. Now, it depends on if you look at the glass half full or the glass half empty. So you could also say, or the shorter segment is half the longer segment. And I'm going to give you a big hint that's going to help you out in solving the problems that we're going to solve. And I'll explain what that says in just a minute. The big hint, the short leads you to find the short. You're going to say 3x is equal to the total length. So it depends on what information you're given on how you roll with this. What'd you say?
Yeah, you can't say that word. They can't say that word, right?
Do I need to give you silent lunch?
You know what I think? I think you should put a desk outside. For the remaining 15 minutes of class.
We don't give silent lunch in high school.
Outside for like the rest of the class.
What if you?
All right, about 45 more seconds to finish copying this, and then I'm going to flip over. All right. So let's begin by looking at our examples here. These problems are going to look difficult, but this is a scenario where don't judge a book by its cover, because these are not that difficult. But what I suggest doing is to always write down what you know. So here it's called circumcenter. So if it's called a circumcenter, what are we working with? Circumcenter. The circumcenter is made up of the perpendicular bisectors, and the longer segments are congruent. All right, so we can see the point of concurrency right here. That is your circumcenter. That's what all the points are intersecting, right? All right, so our longer segments, all right, this goes from the center to the side, but our longer segments, if we go back to the diagram we drew and looked at, it's not from the center to the side, it's actually the other segment. So here, we're talking about this segment, and this segment. Those are the three congruent segments right there, the longer segments. So now let's read into the problem here. They want to know AG. All right, so here's AG. That's one of the yellow segments, isn't it?
Yeah.
Do we know what one of the other yellow segments is?
CE, ICF.
CG. What's the length of CG?
25.
So if that one's 25, the other two are also
25.
25. So AG is 25.
25.
All right, CF. That's this one right here. Well, these are perpendicular bisectors. So what's happening to AC? It's split in half. So if this half is 24,
Half to be 24.
this half is 24. So see, it's not that difficult. The difficulty is just knowing the properties. All right, CE. Well, again, this is being bisected. So if this is 15, then this is also 15. All right, BD.
20.
All right, so this whole side AB is being bisected. So if this is 20, this is 20, so BD is 20. All right, AB, they want the length of the whole side. 20 plus 20 gives you 40. All right, AC, they want the length of the whole side.
44.
48. I like that confidence, though. You said it with conviction.
I'm dyslexic. That's not funny.
All right, ADG. ADG. All right, these are perpendicular bisectors. So if these are perpendicular bisectors, what's the measure of D? 90. Because again, they are perpendicular bisectors. And finally, probably the hardest one, because you have to do the most work for this one. If BG is equal to 2x minus 15, so this is also 2x minus 15. But we also know it's 25, right? What is x? So when two things are congruent, do you set them equal to each other, or do you add them and set them equal to 180? Set them equal to each other. Congruent means they are equal. So we say 2x minus 15 equals 25.
Hey, to interrupt. Congruent means equal?
Yes.
Learn something every day. Let's see here.
All right. Heading back.
I can do this one right now.
All right, so give it a try. All right, so do the U try underneath here.
Transpose -15.
So it's still a circumcenter, so do the U try.
Is there any difference? For MO. All right, so we know that the longer segments that I have highlighted here are congruent, right? So see if you can figure out what the length of one of those other segments are. You just know the answer because you're given the answer. All right. What do we know MO is, everybody? Right. It is 26.8. MN. Now MN is the whole side, so pay attention. Very good.
48.
PR. Very good. SP. MQO. Alright, they're perpendicular bisectors, right? So MQO. What's this angle right here going to measure?
90 degrees.
Alright, if OP is 2x, what is x?
2.
So 2x equals, so when we divide by 2,
$13.4. Oh, lock in, baby.
sure will. Thank you. All right. For the end center, all right, that's the angle bisectors. Okay, so if you're given the whole angle, you either divide it by 2 and set it equal to what you're given, or if you're given the little angles, you add them together and set it equal to what you're given. I want to skip this one and I'll come back to it if we have time, but I want to go ahead and go to the centroid. All right, the centroid is the important one. So right here at the bottom where it says centroid. All right, RH is 2. Pay attention now. Is RH the shorter segment of HW, or is it the longer segment of HW? It is the shorter. So if the little piece is 2, what's the longer piece? 4.
My brain needs to be studying actually.
There's more than one page. You gave them the right for homework.
You know at one point.
All right, for the next one, FJ. All right, they want us to find FJ if ZF is 6. Is ZF the shorter segment or is it the longer segment? It's the longer, so then that makes the shorter one what? 3. So do you see what I mean by the 2 to 1? One is twice the length of the other, or one is half the length of the other, depending on which way you look at it. All right, CY. All right, you're given that SY, the whole length, is 33. Now this is the most difficult one, but it's easy if you follow my directions. The longer segment is twice the length of the shorter, right? So it's a 2 to 1 ratio. So when you have ratios, you add them together. What is 2x plus 1x?
3x.
So 2 plus 1 gives you 3. So you notice where I said big hint, set 3x equal to your length. When you're given the whole segment, you're going to say 3x equals whatever the whole segment is. So what is our whole segment? 33. So then x would be what? 11. So 1x would be 11. So the shorter segment is 11. What's the longer segment? 22. So CY would be 11, and if they wanted SC, it would be 22. So these are the 3 scenarios. You're either going to be given the shorter segment and have to find the longer. You're given the longer segment and having to find the shorter. Or you're given the whole segment. When you're given the whole segment, set it equal to 3x always. And when you solve it, it gives you the shorter segment. So if they didn't want the shorter segment but wanted the longer segment, my answer would have been 22. So do you see how the centroid works? So it's an easy thing to work out, but it's hard to remember the concept. So the more you practice, the better you'll get. All right, I think he gave you, what, 12 problems? Is it 12 problems on that worksheet? Or 8? 12. So to complete those 12 problems, show your work. And your work is simple. Some of it's just as simple as labeling the diagram. Okay? So like right here, my only work was to label the diagram. That's homework for the night.